Welcome to this channel again, and today I'll be taking a question related to signal and system, and this is a problem related to finding the fundamental period of a complex exponential signal. So let's start, friends. So this is the question, which says that what is the period of the signal xn equal to e power j 6 by 5 pi n plus 2 by 3. Okay, so we need to find the period of the signal, this exponential signal. So before proceeding to this problem, we can have some mathematical clarity regarding this exponential. So we know that e power j theta is given as cos theta plus j sin theta. Okay, and if to this e power j theta, if I add e power j 2 pi k, where k is a positive integer, k is a positive integer, okay, k is positive integer, then again what I get is e power j theta, because e power j 2 pi k is 1. Okay, so this is the property where k is an integer, positive integer. It can be a negative integer also, but for our case, let's say it's only a positive integer, so it's always 1. Okay, so we will be using this for finding the period of this signal. Okay, so let's start. So first, what is periodicity? Periodic means if x of n plus n is equal to x of n, okay, where n is an integer, n is a n is an integer, positive integer. Okay, so it's, if it is a positive integer and this property is satisfied, means after n samples again we get x of n. Okay, so the signal is considered to be periodic. Okay, so what we do is we now we already have x of n and we need to prove this as equal to x of n. So what we do is we start evaluating x of n plus n. So let's do that. X of n plus n, so instead of small n we can put x of, we can put n plus capital N. So let's do that. 6 by 5 pi small n plus that capital N plus 2 by 3. Okay, so now what we can do is we need to make it equal to x of n. So can we make x of n out of this part? So let's make that. So let's again write it and see whether we can make it. So let's multiply with pi. We can take the pi inside. Okay, and 2 by 3. Okay, so you can see here that pi n and this pi n and this 2/3 and this 2/3 are already there. So we can write it like this: e power j 6 by 5 into pi n plus 2/3 plus pi and capital N. Okay, so you can see that this is what we need. Okay, so we can again write it like this: e power j 6 by 5 into pi n plus 2 by 3. Okay, into e power j 6 by 5 into pi of capital N. Okay, now see, this part is x of n. Okay, and this is the part which we want to make it to 1. And if we make it to 1, if we are able to make it to 1 for some value of n, for some positive integer value of n, then we say that that is the period. Okay, and that should be the smallest n value, not because it can be the multiple of that small value. So we have to find that smallest n which can make this go away. This means make it 1. So what we can do is, again we will be using the property that we stated earlier, this property. So what we can do is we can equate this to e power j 6 by 5 pi of capital N, and we equate it to e power j 2 pi of small k. Okay, now you can see that we can compare these two. Okay, so if we compare these two, we get of capital N is equal to 2 pi of k. Okay, so see, these 2 pi get cancelled and from here we get n is equal to 2k into 5 by 6. Okay, now you can see here that can we make this an integer? Yes. For what value of k? If we put k equal to 3 here, then we get n is equal to 2 into 3 into 5 by 6. Okay, and this goes and n becomes equal to 5. Okay, so we can make uh, it periodic, or we can make this go to 1 if n is equal to 5. Okay, and multiple of that means if you make it 10, 15, 20, then definitely it will go to 1, but the smallest value is 5, so period is 5. Okay, so this is how we need to proceed for these kinds of problems. Okay, we have to remember here that the discrete time system period will be always a integer, so it cannot be a non-integer. Okay, and hence we need to find a smallest value for which gets satisfied. Okay, now there can be cases in which the signal may not be periodic, so in that case you won't be able to get an integer value of n for which you are able to meet the above specified requirements, or if you are able to meet the equation, that is this one, the one I am highlighting again, this equation will not be again satisfied, and hence you will be able to conclude that the signal is not periodic. Okay, so thanks for watching.